Okay, I'm going to do a video on section 3.5. Okay, this is on compound inequalities. And here in the beginning of the video, I'm just going to focus on the graphing aspect. Okay, so I'm going to do some different x's greater than or equal to 1 and x is less than or equal to 3. Now, to graph that, we have two action points now. We're just showing both. Greater than or equal to 1, of course, would be a closed circle and go up there forever. Less than or equal to 3 would be a closed circle going down forever. Now, that's not our final answer, though. So when you have the word and means that you have to satisfy both criteria. You're looking for the zone where you have both graphs. So you see here above 3, you only have one line, this lower one, which goes on forever. Below 1, you only have one line, this upper one that goes on forever. But in between 1 and 3, you have both. So your final answer would be a barbell-looking thing like this. You're looking for the overlapping area is the short answer when you're doing an and problem. Okay, where do you overlap? Now, sometimes they may go in the same direction. Oops, let me have a little bit more room here. So in this next one, it's very similar, but it says greater than or equal to 1 and greater than or equal to 3. So the overlap, of course, where do you have both? You have both up here from 3 on up going on forever. So your final answer would actually be this. Because down here you only have 1, down here you have nothing. So you're looking for the zone where you have where you have both of those lines. Okay? Now sometimes you might have something strange like this. X is greater than 3 and x is less than 1. Now when I go do that one, 1, 3, I have an open circle and I'm going to the right from 3, and I have an open circle and I'm going to the left from 1. Now here this says and, so you're looking for the overlap. These don't overlap at all. So this actually is no solution. There is no number in the world that is bigger than 3 and at the same time less than 1. It's not possible. Okay. Now let's go ahead and explore some the similar things, but we're going to change the word. Okay. So we're going to do x is, let's do x is less than -1 or x is greater than 2. So I'm going to set up my number line. -1, 0, 1, 2. Greater than 2 would be an open circle going to the right. Less than -1 would be an open circle going to the left. Or means you only have to satisfy one of the criteria. So where do you have one graph? Well, you have one graph up here, bigger than 2. We have another one down here. This is actually your answer. If it had been and, it would have been no solution. But because it's or, this is actually the answer right there. You're actually done with that. Okay. Now what happens when they go in the same direction? So watch this. X is greater than or equal to 0 or x is greater than 2. So we have 0, 1, 2. Greater than or equal to 2 would look like that. This one would look like this. So you never leave your answer like this. You got to do a final answer. But remember, when we had an and problem, we were looking for where you had two graphs, which would be this. When it's an or problem, you're just looking for where do you have at least one graph. Well, below 0, you got nothing. Okay? Between 0 and 1 and 2, you got 1. And to the right of this, you got both. So both is okay, 1's okay. So your final answer would be this, from 0 all the way on up. Okay? It's okay to have 2, it's okay to have 1, but not 0. And then sometimes you could have something weird like this. X is less than 3, or X is greater than 1. So greater than 1 would look like this. Less than or equal to 3 would look like this. Where do you have at least one of these lines? Well, it goes up forever here. You have both in between. You have one goes on forever below. This is actually all real numbers. Every number in the world is bigger than, every number in the world is smaller than or equal to 3 or bigger than 1. Okay? This is all real numbers. You have at least one of those lines. Okay, let's get into some solving that you're going to see. Not a big deal. 8 plus 2x is less than 6, or 3x minus 2 is greater than 13. So what you do here is you just solve these both kind of independently. Move the 8 over. That'll be negative 2. Do a little division. X is less than negative 1. Don't forget to bring this word down because that's part of the problem. We're going to move this 2 over. So we get 3x is greater than 15. And we get x is greater than 5. Now remember, it's an OR problem. So you only have to satisfy one criteria. One of the two criteria. And your answer is just like this. You just leave it like that. A lot of times an OR problem will look like oars of a boat kind of sticking out in both directions. A lot of times, but not always. Okay, now here is a classic, this is a double inequality. And when you have this essentially is an AND problem. You want to get x by itself, but now you got to get x by itself in the middle. You have a middle zone, you have a left zone, you have a right zone. So let's get rid of this 8, but we have to add 8 in all three zones. So we get 6 and we get 18. Now we divide by 3 again in all three zones. So x is between 2 and 6. And whenever you have this double inequality, you're always going to have, whoops, that should be an open circle. You're always going to have a barbell looking final solution. Okay, not too sure why it skipped up like that. In other words, this is x is between 2 and 6, and we just indicated that right there. All right. All right. I'm going to show you just one more here. Of course, we do a lot more in the Zoom, but this is just kind of a short. Let's go to number 9. Let's see if I can fit it in here. So let's do 17 is less than, this is another double inequality, less than 29. You want to get x by itself in the middle. So we move the 5 over, and we get, what's that going to be, 12. And that's going to be 24. Now we have to divide by negative 3. Now remember, we're dividing by a negative. So the inequalities, both of them switch. So x is in between negative 4 and negative 8. And it's always a barbell when you have this double inequality. -8, -4, bam. That's a real short version. Much more detail on our Zoom lesson, of course, but that's really for section 3.5. All right.